Okay. All right. So now let's look at another example, which is actually more realistic. So this study was done in a Wisconsin hospital. So we are trying to detect breast cancer, okay, using machine learning. So this study was done, of course, the reference is provided here. This study was done in a Wisconsin hospital in 1992. And what did they do? They did biopsies of incoming patients, and then they characterized the cell for various properties. Now, I do not have oncology or any medical background, so please don't ask me what actually those properties are, but that's what they did. Okay, and the objective was, if some new patient is coming in, we want to know whether this they have malignant or benign tumor. That's the objective, right? That's why we are trying to do this. Now, how we are going to do it? We're going to use a technique called supervised machine learning, and I'll explain what that term means in a minute. So everybody clear on the setup? We are going to train the data with some cell properties or biopsies, and then we're going to make a prediction whether a new patient would have malignant or benign tumor. Okay, all right. So let's look at that. So what I have here is the results of some of that work that was done. Of course, I only selected some records just because I didn't want to fit 300 records in my slide. So what we have here is a situation where, in our previous machine learning example, right? The target variable was a sales price. It was a number. It was a dollar amount, right? But it doesn't have to be. It could also be a category. It could be, in this case, we are trying to detect whether they have cancer or no cancer, right? Malignant or benign tumor, right? So your target variable can also be a category. It doesn't have to be a number. That's number one, okay? Now, let's get familiar with some of these terms. We are calling this technique in general, whether that house or sales or this one, as supervised machine learning, is because we are providing training to the model, right? So that's why the term supervised comes in. Okay. So now let's just get familiar with some of these terms. Um, each column is called a feature in data science speak. Okay, so it is a feature. So there are multiple features: cell thickness and cell size, blah blah blah. I don't know half of what that means, but one key feature is this target variable. And notice that instead of a number, it is a category, right? It is benign or malignant tumor. Again, try to relate this to your scenario, right? If you are in marketing, are we going to win the contract or lose the contract, right? Or if you are in finance or share market, do you want to buy the sell or sell the stock, right? If you are in HR, do you want to take this resume in or reject it? It could be a category, right? Now, what we have done is we have, again, let's say you had 100, let's say they had 100 patient data coming in, right? They randomly split that data into two parts. Remember, training set, which I've color coded in green, and then the testing set, which I've color coded in yellow. Of course, they're actually random. I'm just listing them in a sequence just for ease of visualization. But they were randomly picked. 80% random data training set, 20% random data into testing set, right? And then, of course, we're going to train the model. Remember these 4 steps that I talked about, right? Split the data, train the model, improve accuracy using your testing set, and then make predictions. So then we will make predictions on unknown patients. That's our objective. Okay. All right. So that's the objective. So let's learn one simple algorithm now, actually how it works. So this is just an example. There are many like that, but this is just one example. So the name of this algorithm is called K nearest neighbors, or KNN. It's a very popular model. So how does this work? Imagine that I just picked 2 of the properties. Now, actually, this algorithm will done on all properties, but for the sake of visualization, I'm selecting 2. Again, remember, the actual model will be done in all of them. Okay, this is just graphical representation of 2 properties: cell size of that biopsy and the bare nuclei. Okay. Now, each of these dot is a patient. Okay, each of these dot is a patient, and they're color coded, meaning, let's say the red dots meaning that biopsy was benign. The blue dot here means it was malignant stage 2, and green dot here could mean malignant stage 3. Let's say. Okay, so we already have this data. right? From patients, then the doctors have already characterized those cells. Okay. Now we have this unknown patient coming in, which I'm representing by this black color dot. Okay, unknown patient coming in with a, and we want to predict whether this particular patient has cancer or no cancer, right? Or whether either biopsy is malignant or benign. So what we do is we could look at the nearest neighbor, right? Essentially, that means setting k equals 1. So you set k equals 1 and look at the nearest neighbor and say, okay, this nearest neighbor was benign, so my unknown patient is also benign. You could make that prediction. Now, I would argue that it is risky because maybe that patient had some unique situation, right? So it is too risky to set k equals 1. So let us increase the value of k to say 3. So now we make the circle slightly bigger, and now we have the nearest neighbor was red and the other two are blue and blue. Blue is malignant stage 2. So we can make a prediction that, oh, this new patient has malignant stage 2. We can make that prediction. We can take the same thing, make the circle even slightly bigger and set k equals 5, right? And now this is what we have. It looks like we still have blue in the majority, so we can make a prediction now is that this unknown patient has malignant stage 2. So this is how we make predictions using this algorithm called KNN, or K nearest neighbors. Now, I would like to, can this be applied to heterogeneous data sources? I would need to understand a little bit more on what you mean by that. But in general, this model can be applied for any data actually. Right? You just have to have the data in this form so that all those properties are identified, because remember we are trying to develop a model on those properties, right? So as long as the data is visible and available and clean, meaning sometimes there's missing data, then let's say you have data but one of the columns is one of the data points is missing, then you obviously cannot use that data, right? Or you have to manipulate the data and modify it. Oh, coming in different formats like email. Oh yeah, these tools are available that will do all the cleaning for you. The easy. So one thing I would mention, and I was going to say this for the last piece, which was for people who are really serious, but I can tell you is that when you're doing any machine learning application, 80–90% of your effort is actually in cleaning the data. Unfortunately, the fun part, which is what I talked about, is really the last 10 piece. Because if I can get the data in this clean format, then I'll show you. When I give a demo, it'll be clear. It'll take me 10 seconds to run the model, right? It's really bringing this data in this form, cleaning it up, that takes a lot of effort. How to select the training time bias from selecting? No. Okay, good question. How to select the training? You actually do that randomly. There are commands in Python or any tool that will allow you to randomly pick. You can say, give me 80 points, and then it'll pick 80 points for you. And when I'll just hold on to that, and when I give a demonstration using that software, it'll be clear. Okay. Okay. So where was I? So I was talking about this particular application, right? Where I demonstrated how, I explained how KNN works. One question I would expect from you is, how do you set the value of K? Now, remember what I talked about in step 3, right? We do hyperparameter tuning. So imagine that the K value is a variable now, right? So you set K for a range from say 3 to 50 and find out at what value of K you get the best accuracy. And that's the value of K that you set. This technique is called hyperparameter tuning.